We're going to talk about the Cartesian coordinate plane that we use to graph. So the definition of the Cartesian coordinate plane is a plane divided into 4 regions used for graphing. Take a moment to pause the video to write down the definition and also label the parts of the coordinate plane. When you've finished, resume the video. When you draw the x-axis moving horizontally across your plane and the y-axis moving vertically across your plane, they intersect at a place we call the origin. Also, the plane is divided into 4 parts, and we generally label them with Roman numerals. In the upper right-hand corner, this part of the plane is called the first quadrant. And then if you move around counterclockwise to the left, you have quadrant 2. And then if you move down to the lower left, you have quadrant 3. And finally, the lower right is quadrant 4. Every point on the plane can be accessed with ordered pairs. Every point has an x and a y value on the graph that describes its location. Here we have some points labeled with capital letters on a coordinate plane. The origin is where the darkened lines, the x-axis and the y-axis intersect. What we're going to do is find the ordered pair that represents each point and determine which quadrant the point is located in. Let's look at point A together. When you find the coordinates of a point, you always begin at the origin. The first coordinate tells you to move right or left, and the second coordinate tells you to move up or down. So always move along the x-axis first, which is left and right, and then you'll move up and down. To get to point A from the origin, I need to move to the left 1, 2, 3 units. That's an x-coordinate of -3. Then I'm going to move up 4 units. 1, 2, 3, 4. So the second coordinate for point A is 4. And I've written the ordered pair with a comma separating them and parentheses around them. You will notice that point A is in quadrant 2 on the graph. Pause the video and see if you can find the other ordered pairs. Then resume the video to see if you're correct. Let's go over the remaining points. Again, always start at the origin. For point B, we'll move to the right 2 and down 3. That's the coordinates 2, -3. Up and right are positive directions. Left and down are negative directions. For point C, we don't move left or right at all. So that's why C has an x-coordinate of 0. We only move up 2 units. Remember, the first coordinate tells you how far to move left or right, and the second coordinate tells you how far to move up or down from the origin. You'll notice that point C does not lie exactly in a quadrant, but rather on the y-axis. For point D, from the origin, I will first move 1, 2, 3 units to the right and 1 unit up. So point D is 3, 1, and it's in the first quadrant. For point E, from the origin, I move to the left 2 units. So that's an x-coordinate of -2 and down 3 units. That's a y-coordinate of -3. And I end up in the third quadrant. Finally, for point F, I'm going to move to the right 1, 2, 3, 4, 5 units, and then I don't move up or down at all. So F has the coordinates 5, 0, and F lies on the x-axis. When we plot points like this is called a discrete graph. A discrete graph is simply a graph of distinct points. You could count the number, whether it be a few points or lots of points. Sometimes, many times, we will deal with what's called a continuous graph. This is when there are infinitely many points graphed and they're connected by a smooth curve. You don't have to pick up your pencil to draw all the points this time. So this curve represents all the points along the way, infinitely many of them. And so when you draw a curve such as this one, you call this a continuous graph rather than a discrete graph.